So are we waiting? We are waiting for the slides, and I want to introduce my name because Jared just asked me how to pronounce your last name. I said my name is Catherine Cao, and I repeat 3 times, and he said I will just say your first name. So Catherine Cao is my name, and I'm Chinese, and my Chinese name is Ying Cao. So you can call me Catherine or Ying, so it's up to you. And my talk today is Experience R in the cloud. And when I received this task, they asked me to demonstrate our platform called Data Science Experience. So I prepared it in a way more like a sales pitch. So for those of you who are looking for a very serious tech talk, I'm sorry. I'm asking you to do me a favor, that I'm ensuring you we will have a break in 40 minutes with free food and free drinks, because we are the sponsor, okay? Anyway, so this is a project we have been working on recently. So that is something we do to help our customers in insurance industries to leverage the power of analytics to help them to optimize their insurance operations. So let me just first start with the scenario. So this is our insurance company located in your area, always hit by extreme weather conditions. So every time that occurs, they will see a very increase in their claim amount. So they do not know how could they prepare for it so that they can know that how many resources they need to cover those claims. So this condition actually poses a lot of pressure on several lines of business. These are the questions asked by the line of business. So first, from the question from finance and planning department. So they really want to know how many claims they should anticipate so that they can plan the amount of the reserves. And then claim operation assessment, they want to know how many claim adjusters is needed for the upcoming volume. And then about claim operation settlement, they're asking how we could make the whole handling process more efficient. And then the fraud unit, they're asking what are the claims that what are the cases that is suspicious, and we need to further investigate those cases. So they just throw out all these questions to the data science team, and I think this is a very typical scenario because we have a couple of data scientists working on the team, and they have their own preference about the tools they would like to use. So we have R users, loves R, just wanted to work with R only. And the second one is Python users. And we also have some non-coders working on the team as well. They are using more mature product like Modeler. So our platform will just bring them together onto one unified environment to work on this project. So this is the proposed workflow for this whole project. We identified 3 use cases. The first one is we wanted to do a prediction about the future claims which we could expect. And this will be done in our built-in Rstudio. And then there are 2 pieces of data we want to leverage. And the first one is historical claim data. That is something they already have. And the other one is weather data, because in this scenario, apparently, that is something will be very important for the prediction. And then second one, after they gain some insight about what to expect in the future, and then they want to do some prescriptive analysis about what to do with all this stuff. And they want to optimize their claim handling. And this project will be done in Python Jupyter Notebook. And there is one more IBM offerings leveraged here. It's called Decision Optimization Center. And what it does, I will just talk about it in more details later. And finally, after the adjusters collect the data from their site field from the claimant, they will just run some anomaly detection on the data so that they could reduce manual workload by automating the review process. And this will be done in Canvas by the non-coders. And the whole thing will be accomplished on our data science experience platform. And a quick survey question. How many of you here have ever heard of our platform? Hands up if you. Really? Because we're right there. We have been here for Okay. Okay, that's good. So we're right there. If you want to learn more, just visit us there. Okay. So I will just give you a quick overview of what it is. So the idea of this platform is that we want to bring together everything the data science community like together in one place. So you can learn from the community here, and you can create data assets on the platform, and you also could collaborate with your team and the broader data science community together, just within one place. And here, all the components will be shown later. So let's get started with use case 1. So this use case is used to help the company to know how many resources they have to reserve for the upcoming busy business seasons. So this is the user interface of our built-in Rstudio. So you would find that it's actually exactly the same, like the one on your desktop. So thanks to our partnership with Rstudio. So the benefit is that there's actually no learning curve for the users. So you're actually working within the environment that you're very familiar with. And as the screenshot shows that we are loading data from one very popular weather API called Weather Underground, which is a weather service provided by the weather company. If you know that recently IBM has just acquired the weather company. So they provide really, precise like weather measurement. So that is the data we will be leveraging. And then we wrote an R notebook to analyze the data. And on the top left is the table of content of the notebook. So it's basically everything we've done for this use case. And we just, like every data science project, we just do some visualizations to know better about the data. And here are more visuals, because essentially they want to test like whether or not the weather can be a very informational variable to predict clean volumes. So especially for the one with snow, you can see that they're like the trends go together very closely with each other, which indicates that that could be used to predict our outcome variables. And then for the forecasting part, I run a linear regression using the linear model from the Spark machine learning library. So that is another benefit that can be delivered by this platform, is that you can access our managed Spark services within like 2 lines code. This is the Sparkly R package developed by Rstudio. So just 2 lines of code. You don't have to configure your own environment. And then it can be used to process large scale of data set. And this is use case 1. And the second one is about like, now we know how many claims we will have in the future, leveraging the weather forecasting data. And then we want to know, like after some customers make a claim, and the insurance company will definitely send an adjuster to investigate the case and to determine to which extent they will get you covered, right? So, but the question is that they only have this amount of adjusters, but some special event happens, they will have this amount of cases, how they could leverage their existing human resources to cover this kind of special conditions. So they definitely need to improve their work efficiency for each adjusters. So the idea is that there's a couple things we want to achieve. The first thing is that we want to send the right adjusters to handle the right case so that they are experienced. So they could they know how to handle the process very efficiently. And second one is we want to let the adjusters to show up at the client door at the right time, which is expected by the client. And the third one is we really want them to cover as much cases as they can every day. So that's how we could like bring the best experience to their customers. So this is like all about planning and scheduling. So, and we have the offering called Data Utilization Optimization Center. What it does is to help you plan out the logistics so that you can make sure that all these objectives can be achieved. So this is a Python notebook. What it does is we access the service API, and we just connect to it, and we set all the goals, business rules within Python code, and then we just let the service to handle the optimization problem for you. And the map shows that shows the logistic recommended by the service for two of the adjusters. So this is the part two. So we solved another problem. It's about how-to problem. And finally, because the adjuster is actually collecting more data about the cases, right? So after they coming back from their field visit, they will just feed the data to the fraud detection unit. So what they will do, they will run some anomaly detection algorithm on this kind of data, so then they can automatically identify the suspicious cases for further review. And this is done in Canvas, as we mentioned before. And if you don't know what Modeler is, and it actually the cloud version of SPS Modeler, what it allows you to do is that you don't have to code. I think that would be something maybe funny to speak here, but we do have a lot of customers still very interested in this kind of product because they can really focus on the business questions instead of like coding, things like that. And you just drag and drop the node to the canvas, and then it will just actually just run the code at the back end. And that is how non-coders can solve analytics problems. And as the scatter plot shows, the green one is the normal cases, and the yellow one is the one that is suspicious and need to be further reviewed. So that is the whole process, all the effort made by the data science team to like deliver some insights for the line of business, like what they do, what they could expect, what they do with all the data they have. And actually, as I just showed, because we have more things on our platform that you can test out, and we do offer 30-day free trial. You can try it out and have your experience. I do hope that you could let us know like how you like it, like maybe something you dislike, and we could just like working together to make this platform better for the data science community. Thank you so much.